Structural design considering the true seismicity of a location in the Philippines. This is a plot of historical earthquake events in the Philippines. Larger magnitudes are indicated by larger circles. As you can see, some areas have more earthquake events. Therefore, it is clear that seismicity vary in every location in the Philippines. In the current NSCP structural design standard, the code recommends to assume Zone 4 for all locations in the Philippines. This assumption does not reflect the actual seismicity of the location. Therefore, to enhance the safety of structural designs, a probabilistic seismic hazard analysis or PSHA, which considers the statistical approach of the historical events and its corresponding acceptable risk, can be used in addition to the NSCP recommended approach.
How to use PSHA procedure in the seismic analysis and design and why there is a need.
Some of the reasons are the following. 1. The use of PSHA in addition to the standard procedure supplements the shortcomings of the code-nominated procedure of using a deterministic and single zone for the whole country. 2. Allows the engineer to designate the design life, which is the number of years the structure is to remain useful. This is not possible using only the code procedure. 3. PSHA is necessary for performance-based earthquake design.
The following demonstrates how to add load cases using the actual seismicity of a location in the Philippines and use them in the structural design.
In the Loads menu of Frame CE, there are two ways to generate lateral seismic loads. The lateral seismic loads generated using the button group called Seismic Load is for the code-nominated equivalent seismic loads. Another button group called Dynamic Analysis is to generate the lateral seismic loads using the response spectra of a ground motion time history. Frame CE conducts a probabilistic seismic hazard analysis or PSHA of the location and generate the response spectra of the simulated earthquake motion, which can be used as one of the load cases for the design. The procedure is demonstrated in the following video. Go to Loads menu and click R-Spectre button of Dynamic Analysis button group. Click Menu button and select Simulated Response Spectra, then Probabilistic Seismic Hazard Analysis. Designate the design life of the structure and the exceedance probability within the design life. Click PSHA button and Frame CE will generate the response spectra based on the seismicity of the location and the exceedance probability. Click Export Response Spectra button. Designate the load case name, the seismic lateral loads direction, then click the button, Spectral Loads. Frame CE will generate the lateral seismic loads. Click the button, Spectral Loads. Frame CE will generate the lateral seismic loads. You will now have two types of primary load cases for seismic loads. 1. The seismic load case using the NSCP standard procedure and 2. This PSHA-generated seismic load case. This ensures a more extensive seismic analysis for the design by considering the actual seismicity of the location.